Now you can find simple and compound interest using tables like we did previously, but it's a little bit easier if we use a formula. And there's a relatively simple formula for simple interest that's pretty easy to work with. It's A equals P plus P times R times T. Now, to use any formula, we need to understand what all of these variables represent. So let's go through them. A is considered the future value of the investment. It would be how much you have after you've been earning interest over so many years. So the future value of the investment having earned interest over a certain period of time, T. P is what we often refer to as the principal in economics. But another way to think about it is as present value. And basically what that represents is the starting amount or the amount you start with in the investment. R is the interest rate, R for rate. And it's generally the annual interest rate expressed as a decimal. So because we're going to calculate with things, even though in the application they might tell you that it's an 8% interest rate, you want to, for the sake of the formula and the calculations, express it as a decimal. And finally, T is times. T stands for time, but in particular, it's the time in years. It must be in years for this formula to work properly. All right, let's look at two examples. The first one is actually what we did with the table on the previous example. You invest $5,000 in an account earning simple interest of 8% annually. How much will you have after 5 years? So we're going to use this formula. A, the future value, is equal to the principal, which is what we start with. That's the 5,000, plus 5,000, again, times, and then we'll have the interest rate. The interest rate is 8%. Remember to write it as a decimal, 0.08. And then the number of years or the time, 5. If you're doing this by hand, remember that addition comes after multiplication. So you must do the multiplication first and then add the 5,000 that was at the beginning afterward. However, if you were doing this in a scientific calculator, you can just plug the whole thing in and you will get the answer. All right, so scientific calculators do know how to do order of operations. So 5,000 plus 5,000 times 0.08 times 5 will give you a total of $7,000, which is exactly what we did when we did this year by year with the table. Let's look at one that's a little more interesting, something that we haven't done yet. Say you need to pay back a $600 loan that you borrowed 3 years ago at a simple interest rate of 6.7%. How much do you pay your lender, and how much interest did you have to pay? So there's a difference between those two. Let's look at how much you have to pay your lender first. That would be the total amount that at the end of the loan you have to pay. Well, that would be the future amount that you're paying for the loan. So A equals, you started with a $600 loan. So 600 is the starting amount or the principal, plus 600 again, times the interest rate of 0.067. Remember, converting a percent to a decimal, move the decimal point 2 places. And then the time is 3 years. Calculating this with a scientific calculator, 600 plus 600 times 0.07 times 3 comes out to be $720.60. Is owed after 3 years. That's what you have to pay back after the time period has passed. Those 3 years have gone by. Now, how much interest did you have to pay? Well, let's think about interest here. The 600 is what we started with. And so anything extra beyond the 600 would be what we're paying in interest, not just paying back the actual amount that we borrowed. So in fact, interest is always generally calculated by taking the total amount or the future value and subtracting what you started with. So A minus P. So the interest here would be $720.60 minus the $600 that we originally borrowed, and that would be $120.60 in interest. This idea that interest is equal to the amount that you have at the end minus the principal is an important one that we'll address several times.